First of all, today we're going to prepare the oxime of cyclohexanone. First of all, we're weighing out 4.5 grams of sodium hydroxide. We'll be using this along with hydroxylamine hydrochloride to create free hydroxylamine, which will react with the ketone. We want to create a cooled solution of sodium hydroxide, so here an ice cube and a stirred bar in a small beaker. Let's add the sodium hydroxide and a squirt of water to get things going. In just a few minutes we've got a nice clear cool solution of sodium hydroxide. Now for the hydroxylamine hydrochloride, also known as hydroxylaminium chloride. We've weighed out 7.8 grams, which is an equal molar amount to the sodium hydroxide. We're using 10 ml of warm water to dissolve this. The solution cools down as the salt dissolves, so stir for a few minutes to get this into solution. Looking good. Here's our sodium hydroxide solution. And we add the hydroxylamine salt solution to this. There's a slight temperature increase but not much. This solution now contains our free hydroxylamine base, which we can use. Now for the ketone. This is 10 grams of cyclohexanone, which is slightly less than 1 molar equivalent compared to the hydroxylamine. Check out our other video for details of how we made this. So now with strong stirring, we're going to add the liquid ketone directly to the hydroxylamine solution. It's worth going slowly because the reaction is exothermic, and you don't want to be breathing in hydroxylamine vapors. You'll see the droplets start to turn white with a crystal coating and float around in the beaker. The reaction is very similar to the way that aldehydes and ketones form a bisulfite adduct. If you want a good yield, you need to stir it for a while and make sure any lumps in the mixture are broken up so that all the ketone has had a chance to react. We use a spatula to break up all the lumps in the mixture and create a nice homogeneous fine white precipitate. We let the mixture cool for 30 minutes, and then set up for filtration. We wash the precipitate with 20 ml of cold water. And then dried as well as we could on the pump for about 15 minutes. So here's our product. Still very slightly damp but around 12 grams of a beautiful white crystalline product, cyclohexanone oxime. This is a quantitative yield. Our plan now is to reduce this to the corresponding cyclohexylamine. To cut a long story short, we did do a trial run reducing this compound using amalgamated aluminium foil. We used methanol and water as a co-solvent for the oxime, and we used a 4x molar amount of aluminium foil, which amalgamated nicely using the solution we prepared before in another video. The foil was nice and reactive, but at the end of 4 hours in the flask with some gentle reflux to assist, there was no amine present at all in the reaction mixture. There are lots of other reducing agents out there that will convert oximes to amines, but we're just wondering if there's actually a reliable reference for using aluminium amalgam. And in particular with cyclohexylamine, because this didn't work for us. So if you know of one, let us know and we'll give it a go. Otherwise we'll be back at some point with the reduction using a more traditional reducing agent. Stay tuned.